All righty. I don't like to bring the P word up, but this is kind of similar to doing a proof, what we're going to do today with transformations, except they're not going to be in a statements of reasons form. All right. Here are the three transformations we've covered so far. Translation, rotation, reflection. Do they ever change the size of a figure? No. So the original and the image are always what to each other? Congruent to each other. And that's what you're going to do today. You're going to tell me, why are they congruent? You're going to say, well, because you rotated. That's why they're congruent. Because you translated. That's why they're congruent. All right? So that's what we're going to show. Why are these two figures congruent? That's what I'm going to still ask you today, but you're going to be using these three words in your explanation. All right? Very basic one on number one. And you'll love how we did this because it's just fill in the blank day. All right? Because tonight on homework, no fill in the blanks. All right? But I want to show you exactly what you need written for a good proof. All right? For a good proof. All right, take a look at number one. Read it through real quick. I got a reflection over a line, triangle A prime, B prime, C prime is the image of ABC. Why are they congruent? Why are they congruent? What did I just do? A reflection. What do you know about reflection? Doesn't change the size or shape, right? So here's what I'm going to need for a solid reason. Reflections are, oh, I got two blanks. What's in the missing ones? They're called, yes, reflections are rigid motions. So you need to state what we did, which is a reflection. You need to tell me the rigid motions that preserve two things. Need a little more than shape and size. That preserve, ready? Distance, which is your side length. So that doesn't change. Or what else doesn't change? The sides and the angle measured. That preserve distance and angle measure. That, in a nutshell, is what I'm looking for in these proofs. You tell me what you did, reflection. Tell me the rigid motions that preserve distance and angle measure. Not too bad, right? So why am I saying you're going to need help from your groups today? Because you're going to have to find out what we did to get from the original to the image. That's going to be the toughest part today. All right? If you take a look, I got ABC and XYZ are graphed using the property of rigid motions. Explain why they're congruent. I'm not going to tell you what we did. That's your job right now in your group. That's your job. All right? And there could be multiple answers here. So I'm going to give you about a minute and a half in your group. How did A go to point X? How did B go to point Y? And how did C go to point Z? What did I do? And also, here's the tricky part. I don't just want one word. If you tell me it's a translation, you better tell me up, down, right, how many. If you're going to tell me it's a rotation, you better provide a degree measure. And if you're going to do a reflection, you better tell me a line I reflected over. All right, so go ahead, discuss it in your groups right now because there could be multiple answers to this. What am I doing to match these suckers up? Get specific, too. Just don't give me a word. Get specific. Don't try to fill in the blanks either. Do not try to fill in the blanks. All I want to know is, in your group, what could I have done to match those triangles up?
No, I'm saying it's also there's no reflection along with it. Why not?
Okay, here we go. Can I hear from different groups? What'd you and your group came up with? How do I get ABC to XYZ? Julia, what's your crew come up with? Rotate. I love it. Rotation 180 around the origin. Anybody come up with it? Because there is a different one out there. That was it. Everyone was rotation 180. So you did X and Y. That's fine. Hey, did I say you had to do one and only one? No, you could have done two. You could have done 3, 4, whatever gets the job done. All right, that's how many you do. So we could have went over the X and over the Y. We could have also reflected, what's that? Through the origin. Okay, we could have reflected through the origin too. All right, I'll go with the rotation one. So ready? The transformation is a rotation. And sorry, I didn't give you a big enough blank here. A rotation of, what'd you guys say back there? Rotation of 180 degrees. And I didn't even say anything, and you said it anyway. That's not good enough. You need the degree measure and where you rotate it around. And what did you guys say? So a rotation of 180 degrees, sorry again about this, around the origin. So you need to give me a degree measure and where you rotate it around. All right, let's fill in the rest now. Since, in this case, rotations, that's what you guys did. Since rotations are rigid motions, and again, I'm just having you fill in the blanks because you're going to write these on your own. They preserve distance and angle measure. Thus, this is the best part. You can write henceforth, whatever. What else do I have? In conclusion. I don't know about sincere. What, are we writing a letter here? What? Anything else I forgot? Furthermore, that's a beautiful one, Jack. Yep, furthermore. So it doesn't have to be thus. It can be anything you want. But in this case, thus, what do we know about the triangles? Thus, triangle ABC, congruent to triangle XYZ. Here's the basic setup of what you're going to write for me now. Yes, Remy, go ahead. Through what? The origin? Okay, remember, reflections through the origin. So I'm going to go from A to X. Ready? So I go over to the left one, down 1, 2, 3, 4, right? Left 1, 1, 2, 3, 4. They would match up. If I wanted to go from C to Z, ready? I go left 1, down 1 to get to the origin, left 1, down 1. So every time I reflect through the origin, it would match up too. Okay? Any others? Because now it's going to get a little tougher. That wasn't, not too bad, right? Most groups could get rotational 180 or something of that nature. We're all good. All right, now I'm going to get a little tougher. Now you're really going to have to work together. Before you and your group go, directions, ready? A prime, B prime, C prime is the image of ABC after a sequence. So I'm not looking for a one and done here. You're going to have to tell me, you do this, then you have to do this. All right, a sequence of transformations. Let's go. What do you got for me? I got to do this, then this. Or maybe you go 3 of them. I don't care. Whatever gets the job done. 2 or more right now. 2 or more right now. And make sure it works for every point. Get specific. Just don't tell me translation, rotation, reflection. Get specific for me. So do this, then do this. A lot of blanks there.
Rotation would you like us to use?
Anyone's acceptable. Do we have a couple here? And then we'll start writing our reason here. Any group? Actually, no, I'm not going to call him. Any group want to show off here? What do you got? What do I have to do here? All right, this crew over here. Actually, you know what? You guys had your moment of glory. Go ahead, this crew. What do I have to do?
A reflection through the y-axis.
So you want me to, I'm just writing this down. Reflect through the y-axis, then do what?
Translate 0, -3.
Others? Because you could add more. There's more options here. Anything else? That's what I had. That gets the job done. Yep. Everyone good there? Reflect through the y-axis, then translate 0, -3. Okay, so let's fill it in then. So ABC undergoes a, looks like I was looking for what here? Reflection through the y-axis. You got to get specific. Reflection won't cut it. And a translation of, again, you can write it in vector notation. You can write, just go down, of down 3. That's fine too. You can write it in vector notation, function notation. All right, you guys keep going with me. Since, what I'm going to put here? Reflections. Since reflections and what is the other one we did? Translations are both rigid motions. This whole fill in the blank thing's nice, huh? They preserve distance and angle measure. Thus, triangle ABC congruent to triangle A prime, B prime, C prime. Okay, ready to drop the blanks. That was your fun time with all the blanks now. Time to drop it. On this one, though, I'm actually going to tell you what to do. So that's what you're going to have to do in your group first. So if you want to, the triangle's already graphed for you. You're going to take it, ready? You're going to translate it 5 units to the right, 2 units up, and then you're going to reflect it over the line. Whoa, whoa, whoa! I don't think we've experienced y = 0 before. Hold on. Well, y = 2. What type of line you going to graph in for me? All year we've been doing this. Y = 2. Horizontal, horizontal, horizontal. Y = 0. Still what type of line? Horizontal, but now it goes through 0. Give me another name for y = 0. The x-axis. There you go. So you're going to translate it 5 units to the right, 2 units up. Take that triangle and reflect it over the x-axis. Go right ahead. I'm going to ask somebody in a second for their new coordinates. Ready for A prime, B prime, A double prime, B double prime, C double prime for me. 29. Let's rock and roll. Darn right. A double prime. Where'd you end up?
6, -3.
Yeah, you did. B double prime.
9, -3.
Don't screw this up, Billy. C double prime.
9, -7.
There you go. Explain to me why they're congruent. Okay, no more blanks for you. No more blanks. 25 in the house. All right, what'd you do first? You got to tell me what you did.
Triangle ABC is translated right 5 and up 2.
Okay, yep. So it's already been done. So we translate. So translations and reflections, keep going, are.
They're both rigid motions. So
Hold on, I'm got it right here. Translations and reflections are rigid motions, which
they both preserve distance and angle measure.
which preserve distance and angle measure. And then what word are we using here?
Subsequentially. Triangle.
I'm not even going to sub STI.
Give me your best.
That might be the longest word I've ever written. It's probably not even correct. Triangle.
ABC is congruent. Triangle A double prime, B double prime, C double prime.
Thank you. Yes, Caleb. Yep. No. Nope. Nope. What do you mean? So if you said reflections and translations? No. I'm not saying I'm doing one or the other first. I'm just saying I did translation and reflection. So, or are you talking about up top what I did first? No, here it doesn't. That doesn't matter. As long as you don't put in the words, translation first, whatever you did, that's fine. And I am going to do the one homework problem with you before I let you go on your own. Because everything we've done today has been on a sheet of graph paper. What if I'm not on graph paper anymore? And you can't tell me 180, 180. You can't tell me I translate up this, left this amount. Okay? All right, a little more blanks here for you. Write a sequence, so 2 or more here. Explain why those 2 triangles are congruent. Okay, so I'm going to start you off, and I'm going to say rotate ABC clockwise, counterclockwise. It's up to you. About point, because I can't, there's no origin here. So I'm going to have to figure out a point to rotate around. What's a good point to rotate around? If I take triangle ABC, rotate around. Go ahead, Bella. C, B, A, one of the vertices. All right, because you just can't put a random point and call it, point Z. Let's rotate around point Z. No, it's got to be somewhere on here already. It's all right, Bella, take yours. So we'll rotate it around point C. Clockwise or counterclockwise? Because remember, C's got to match up with F. Which way do we want to go here? A with D, B with E. So I'm gonna keep point C where it is, everybody. I'm gonna keep point C where it is. Where do I want to move point A to get to D, B to get to E? Which direction now? Clockwise, yep. So rotate it clockwise around point C. But will that? Go ahead, Christian.
So would it always have to be the one that's like the shortest distance? Because you could rotate it counterclockwise and just match up, but it would just be
That's fine. That's why I said circle one. It doesn't matter which one it would be. Yep, I just wanted to make a decision here. Okay, now, hey, if I kept point C where it is and rotated point A, point B clockwise, are they going to match up? Just by one rotation? No, right? Because C is going to still be there, and C's got to match up where? With F. So I need to do one more thing. All right, and that one more thing is a slide. I have to do a translation. But if you can't tell me left 4 up 2, what's the other way we translated? Through a vector. Bella, which point did you rotate around? C. So how can I match C up with F? By drawing in a vector that would match C to F. Okay, so I'm going to translate along vector. And again, here's the symbol for vector if you forgot, because we haven't had to draw it yet. It's like a half arrow. CF. Now, what if Bella had said rotate around point B? That would have changed my vector to what now? B, E. If she said rotate around point A, my vector would be A, D. All right, whatever point I rotated around, that would have been the start of the vector. So I'm going to rotate it and slide it along that vector. Go ahead.
Does the vector always have to start from the point that you're rotating?
Yes.
Or could it have been like D?
No, it would have to come from the point because this is going to give me, because C stayed where it is, right? So I need to go from C to F, okay? And then we finish this. Rotations and translations are both rigid motions that preserve distance and angle measure, thus triangle ABC congruent to triangle DEF. All right. So keep working in your groups. Everything else should be on the graph, I believe. Yep, 2. Well, 2's not on a graph, but you don't need one. Also, hey, heads up, when you guys get to number 3 with those kites, I'm not asking why they're congruent. I just want to describe a sequence of transformations that maps one onto the other. All right, so you don't need to go in the big explanation on number 3, but you should give me 2 or more that map it onto each other. And then let's see, yes, 4, you're going to give it and prove that they're congruent. Okay? So please read the directions carefully. Sometimes I just want the transformations. Sometimes I want the transformation and why they're congruent.